This is Algebra 2, Lesson 40 on page 181, Abstract Fractional Equations. We have worked with abstract fractional equations. That means all of the terms are variables. All right? All of the terms are variables. We have an equal sign. So what is the rule when I have an equal sign? Eliminating denominator. The difference with this lesson is I am going to solve for one of the variables. I want one of the variables on one side and everything else on the other side. This is exactly what we're doing in pre-calculus right now. But it is a whole lot harder because it's logarithmic equations. Okay? And I'm solving for x. All right, so in the first one, we're solving for x. I always write that so I don't forget. I want x equals everything else. All right, a over x plus m over a equals c. All right, the very first thing I'm going to do is eliminate the denominator, because that's the rule when we have an equal sign. All right, what do I do? What must I do to eliminate this denominator, Nora? Multiply every term by ax. That is correct. Ax. Do not forget to multiply c by ax. Every term has to be multiplied. And before I multiply, I simplify. So in this first term, my x will cancel. In the second term, my a will cancel. So I end up with a squared plus mx equals cax. I'm solving for x. I want every term with an x in it on one side of the equal sign and every other term on the other side of the equal sign. So that's what I'm going to do. I'm going to move every term with an x. I put x in parentheses, in quotation marks, because I may be solving for a in another one, right? But whatever I'm solving for, I'm moving that, every term with that variable in it, to one side of the equal sign, leaving everything else on the other side. So I'm only going to move this term. So we're going to subtract mx on both sides. I'm left with a squared equals cax minus mx. Now, I'm going to factor out x. Factor out the x. Guys, this is exactly what we're doing in pre-calculus. So it's a squared equals x. I'm factoring it out. I'm left with ca minus m. See that so far? Just following the rules of algebra. That's all I'm doing. Now, I'm going to divide by what's not x, because I multiply, I can get rid of the one that it's multiplied by. So I divide by what is not x on both sides. And on my right-hand side, that term eliminates because it is multiplied by x. Remember, we can only simplify terms that are multiplied. So I'm left with x equals a squared over ca minus m. And I've solved for x. Okay, this is the easiest example. They obviously get harder, right? It does next year. It will feel harder, but you're going to follow these same rules. It's just going to feel different. It's just going to feel different. All right, look at example 2. Example 2, I'm solving for m. So we have x over m plus c equals y over a. Just following these same procedures, but except for x, I'm now looking at m. So I eliminate the denominator. What must I multiply by? Every term, Sarah. MA, that's right. Multiply every term by MA. Before I multiply, I simplify, because I can only simplify terms that are multiplied. That's how my denominators eliminate. I'm left with AX plus CMA equals YM. I'm solving for m. I want every term with m on one side of the equal sign, everything else on the other side. So I'm going to move the CMA to the right through subtraction. So subtract CMA from both sides. We're left with AX equals YM minus CMA. Both of the terms, all of the terms on this side, I don't care what side you move to. But since both of the terms have the m in it, I can factor the m out. I'm left with y minus CA in the parentheses. Now because m is multiplied by that binomial, I can divide both sides by that binomial of y minus CA, and that eliminates. So I'm left with m equals AX over y minus CA. All right, let's do one last example. So there are more rules in pre-calculus, but you'll learn all the rules that we're applying now by the end of this year, because we're in logarithms, and we will do the same types of equations that I'm actually doing in pre-calculus right now. But next year, it's going to look something like right, something like that, and you're going to have to solve for x. Okay, but I'm going to give you all the rules for that, and you're going to be able to do that. It's the same. There was no denominator, so I didn't have to eliminate denominator. Every term had an x in it, so we have to do something before that. So you're going to learn another rule. You're going to learn the rules of logs. But it's this stuff. That's what we're doing now in pre-calculus. All right, look at 40.3. Now I'm solving for p, so all of this applies to p. All right, so the initial problem is 6 over p minus ax equals m over y plus k. I always leave space in between the terms because I'm multiplying by something. Michael, what am I going to multiply every term by to eliminate that denominator?
P over 6. Oh,
A
no, P over 1.
PY.
No.
Oh, PY. No, I get it. Yeah, PY.
Do you get it?
Yes.
I only look at the denominators. Got it? PY. Does everyone understand that? Okay. So I'm multiplying every term by PY. Before I multiply, I will simplify. That's how I eliminate my denominators. The first term we're left with 6y minus AXPY equals MP plus KPY. I'm solving for P, so I'm going to move that AXPY over through addition. Sometimes you might have a term on this right-hand side that doesn't have a p in it, so you need to move it to the left. Make sense? So I'm left with 6y equals mp plus kpy plus axpy. Every term has a p in it, so I can factor out the p on the right-hand side. And divide both sides by this trinomial. M plus ky plus axy. I always go back and double check my three terms, make sure I don't have a p in them. So that the value of p is 6y over m plus ky plus axy. Got it?